And I have to say, it took me forever to get all that mud out of my clothes, out of my shoes, out of my hair. But this is an example of fun and yet practical application.
Yes, absolutely. This is an example where we mix fun with education, because while it may seem that these people are having fun, the students are getting an extraordinary education. These students have to design this vehicle year after year to meet certain constraints, to meet certain challenges. So there are materials issues, there are design issues, there are engine design issues, and there is a whole slew of problems that these students have to address to get to the point where you are able to sit in the vehicle and get covered in mud and so forth.
All right, well, next up we need to talk about energy a little bit. We use a lot of energy and power, and we worry about using up resources and the pollution that goes with it. Engineers, of course, are hard at work trying to figure out new ways to make things go and go and go and go.
This is like the stems, the stalk, all the leafy part of the plant.
And this will make a car run.
Yes, this is what's going to make a car run.
Alternative energy. We've heard about it, but what is it?
I'd classify alternative energy at this point as something other than energy that comes from combustion, whether it's from gasoline to move a car or a truck, or the combustion of coal to make electricity.
We need to find a way to stop burning so much fossil fuels and burn more renewable, less carbon-intensive fuels. We're talking about renewable electricity. We're also talking about renewable liquid fuel, something to go in your gas tank.
There is no single bullet, that one solution cannot fit all of our needs. So people who argue, say biofuels are the way to go about, or some other form of energy, are probably not getting it right. We think that we've got to work on multiple fronts, and the hope is that together we have a solution to all the problems that we have in the area of energy.
MSU researchers are taking such an approach. Some develop thermoelectric devices that harvest energy from tailpipe emissions.
This is about the average diameter of an exhaust pipe, so something that would surround this exhaust pipe, kind of like a catalytic converter.
Under ideal considered situations, you should get 5 to 6 watts. Put 8 of them together and you can run a 40-watt light bulb.
So if we can take some of that 70% of wasted heat or wasted energy and convert just a small fraction of that into electricity with this technology, then we can implement that into a hybrid driveline and improve the fuel efficiency of vehicles.
Create biofuels from natural sources like switchgrass and corn waste products.
I've been working to produce liquid fuels from plant material, cellulosic plant material. These are non-food materials like grasses, straw, wood chips, and so forth, for well over 30 years now.
The cellulose is converted into sugars like glucose, and those sugars are then acted upon by different fermentation organisms like yeast, and they convert those sugars into ethanol, which is then distilled and used as a fuel.
I call it grassoline. Okay, so we're talking literally about making grass into liquid fuels.
And produce improved energy storage devices to help make wind and solar power practical.
Alternative energy conversion technologies like solar and wind convert wind energy or the sun's energy into electricity. So there's also a need for advanced and affordable energy storage as well. So whatever improvements we make to electrochemical energy storage devices like batteries or capacitors, they could be applied to transportation for electric vehicles or hybrid electric vehicles, or for stationary power stations.
MSU's record of innovation is paying off. The newly created MSU Center for Alternative Energy Storage Research and Technology was tapped by the U.S. Department of Energy to lead a new Energy Frontier Research Center, one of 46 to be established nationwide. It is today's laboratory research that will fuel tomorrow's economic growth and stability.
I think in the years to come, we'll see a lot of terrific things coming out of this university. And what is more, there's a great deal of interest in making sure that they get translated to the marketplace, that we just don't create ideas. There's also interest in making sure that we take advantage of these ideas and people are helped in the process.
And the land-grant universities like Michigan State have had this charge since their founding of delivering research results that change lives. Very few things impact our lives, like how we fuel our vehicles and how we get around and how we feed ourselves. And so we're talking about a major change in the way that we provide sustainable fuels and food and so forth, how we use land to sustainably generate fuels and generate the same food that we're producing, and do it in a way that's environmentally sound. It's a fun challenge, it's a big one, and it's appropriate for a big university like Michigan State.
I was just listening to some politicians the other day talking about how we need to start thinking, as a country, we need to start thinking about basic research again, and research universities being the hub of where the things that will truly change the world will happen. Is that part of your mission? I mean, do you think of that? I know that's part of what we try to do at Michigan State, but is that part of your day-to-day thought process? How are we going to change the world? How are we going to solve these problems?
Absolutely. You know, for 100 years now, universities have been good at doing basic research, and we continue to be extraordinarily good at doing basic research. But one of the mandates as a land-grant university is to make sure that we translate some of the things that we produce in our laboratory to the marketplace. And that's an extraordinary challenge. It's something that is relatively new because we have been engaged in this activity only for about 5 to 10 years, where we have to make sure that everything that we do has an application and society can take advantage of the kinds of things that are going on campus. So when we talk about wind energy, for example, we are working with companies to make sure that this technology can eventually be translated into the marketplace.
Well, Dean Udpa, I could talk with you all day about this, but we are running out of time. I want to thank you for watching MSU Today in studio, and of course my guest, Dean Satish Udpa from the College of Engineering. I'm Jim Peck, and I'll see you next time on MSU Today in studio.
The preceding program was produced by Michigan State University in association with the Big Ten Network.